Hi guys, we are happy to see you on our second session in Lviv Power BI user group. And by the way, we really miss you guys. That's why we start our user group online event. And as usual, today with us, Taras and Bogdan.
Hello, everyone. Our today's session is about AI in Power BI, and we have a great speaker today, Marcin Szeliga. He will talk about AI in Power BI. Marcin is a Microsoft MVP. He's speaker at many European conferences like Data Science Summit, SQLDay, SQL Saturday, Microsoft Technology Summit, and others. And he's also a university teacher and author of books and articles about Microsoft Data Platform, including bestsellers like Data Science and Machine Learning, Practical Machine Learning. And before we start, I want to say thank you to our friends from Scala company who support us and help us with different organization items. Nastya, maybe a few words about Scala.
Yeah. Thank you, guys. So, hi, everyone. My name is Nastya. I'm Global PR and Marketing Specialist at Scalia, and I'm very happy and excited to be here today. On behalf of Scalia, I want to stress that nowadays it's crucial to support tech communities since we are all on lockdown. Many conferences didn't happen this year, and to keep this our industry alive, we need to support each other and promote networking. So a couple of words about Scalia. Scalia's main specialization is building cross-border IT and engineering organizations and affiliate companies. Mostly we work with customers from Eastern Europe, but also we have a couple of clients from United States. We've been on the market for more than 11 years. Our headquarters is in Luxembourg, and we have global network of offices in USA, UK, Netherlands, United Kingdom. I said UK, and Poland and Ukraine. And as for our main tech domains, we work a lot with technologies like .NET, Java, Python, Node.js, Surely BI. And we have special departments for mobile development and quality assurance services. We consider ourselves as a family of professionals. Our company culture promotes respect, trust, and transparency. We are ethical and honest in dealing with our team and our customers. So feel free to find out more about us on our website, scalia.com, or reach out to me on LinkedIn. And once again, I'm very happy to be here. And on behalf of Scalia and me, I wish all of us a great evening. And thank you.
Thank you guys. And one more thing from our side. By the way, guys, you can drop your question using the chat on YouTube, and we will discuss them on Q&A session. So it seems to me we are ready to start. And Martin, everything at your disposal.
Okay, so thank you for having me. That's a great pleasure. But still, I would love to be at Lviv right now. But nevertheless, it's always good to meet all friends and talk about Microsoft technologies and Power BI in this specific case. So let's start. I'm Marcin Szeliga. I've been working with Microsoft Data Platform for far longer than I'm going to admit right now. Let's just say that I had seen this platform growing, or even bringing to existence. So it started with SQL Server. Now it looks great in Azure. There's a lot of data services available, and my background is SQL actually. So I started with SQL as a DBA and database programmer. Finally, I moved to BI, and from BI it was just a small step to get interested in machine learning or artificial intelligence, and that's what I'm doing right now mostly. At least I try. Because still from time to time, and with pleasure, I've been working with SQL Server or SQL on Azure or business intelligence. So that's me, yeah? As you can see, hopefully. What about the session? So the session is actually, there are some objectives that I will try to deliver during the next 90 minutes or so. The first one, so we will start with small talk about intelligence that will allow us to move to artificial intelligence, and I will compare this intelligence with machine learning. Unfortunately, I have no idea about your experience in this area. Have you been working with machine learning or no? But to be sure that we are all on the same page, I will introduce some concepts at the very beginning. Then we will try to think how this artificial intelligence or machine learning maybe fits into Power BI. So there will be not only slides, no worries. I will show you some demos as well using, and that's important, Power BI desktop, which means that you can redo or you can do the same thing in your own projects for free. Power BI desktop is a free software. You can use it for any purposes in your companies. It's good to have the Power BI account. Also, the basic tier is free, but it's not necessary. So all the things, all the goodies you are going to see during the session are available for free. I will mention that the Power BI Premium tier will help you at some stages, but it's optional. So that's the second objective, explain to you how AI fits into Power BI. And it's a broad topic, so we will focus a part of it. We will talk about some AI visualizations. And at the very end of this talk, we'll go back in this data science process to data preparation phase. And I will show you how you can use this Azure Cognitive Services to get insight from your data, hence improve your models. It will be at the very end because the AI used for this is actually way more complicated than those algorithms using or working behind AI visualizations. So that's the plan for today. Let's start. So now, on the left side, you can see the simulation of human brain. Okay, and let's focus on this left side for now only. That's the intelligent part. So we should think about what does it mean, yeah? What's the definition of intelligence? And the very broad one, the most general one is that intelligence is ability to make decisions based on data. So you will find intelligence in many different things, or the whole world that surrounds you. Let's start with a human. Yeah, we are perfectly fine with taking the data, the stimuli, and process this data using the small things in our brain called neurons. By the way, they are very simple. They are just transmitters, and they work like that. So if the sum of input signals is greater than some threshold, those neurons will emit a signal on their output, and that's it. So they are just combining data coming from different neurons and sending signals to another neuron. And to what's more, those things are pretty slow, relatively slow in comparison with current computer technologies. But there are a lot of them. And the interconnection is massive. And that's the beauty of how our brain works. So it looks like right now we managed to fire up about 30% of our neurons, and then the animation stopped, unfortunately. Hopefully it will be live again sooner or later. But the point is that intelligence is all about making decisions based on data. That's the starting point. But it's not enough. We are live again. It's not enough because it will be good to measure this intelligence. Okay? Right now, you can think that animals are intelligent under this definition. Even trees can fill the water pipe nearby using their roots, and they can crush this pipe to get water if they need it. So based on data, they are taking some decisions. Looks like that. But it's not only about a living world. The simple alarm clock is also an intelligent device. It's been monitoring time, and when the right time, when there is the right time, it will take some decision and send and play music or whatever else. But there is the word of difference between the simple alarm clock and autonomous car. So it will be good to be able to measure this intelligence somehow. For this, we need to redefine the term intelligence. And maybe it will be good to add this part that the intelligence is actually about getting better, on the way of learning. So based on our pure experience, we can learn to take better decisions over time. And with this definition, we are very close to the right part of my screen. That's funny, but that shows you the overall method of machine learning. So right now, we are trying to achieve artificial intelligence by applying machine learning techniques or algorithms to our data. And it's in the basic form used in Power BI. So I will focus on traditional machine learning algorithms. It's all about learning from historical examples or training examples. It's good to have an answer in those examples already. With this, we can apply this the techniques like classification or regression, which works great. But the whole process is like that. So there is a set of hypotheses. So we have no idea what the relation between input variables or features and an output variable or a label is, and we are trying to find this out automatically. So we can shoot a set of hypotheses and test them against the training examples. Some of them will work better, which means that this device, this computer or the software will be able to take better decisions, Some of them will be completely wrong and useless. So we can compare those hypotheses and select based on the loss function. The second, the most important part of this slide is the term loss function, actually. So based on the loss function, we are trying to minimize the loss. We can select the best hypothesis and act upon those hypotheses selected. Okay, so it's trial and error. It looks like that. And how to find those correlations between input variables and an output one is all depends on the machine learning algorithm used. That's important because some algorithms will work only under specific conditions. So some conditions had to be met. Otherwise, this learning process will give you useless final hypothesis. Okay? But that's not always the case. We can also use the algorithm that works in under any circumstances or works with any data. So that's the starting point. The intelligence, to sum up, the intelligence is about making decisions, which means that it's up to us to make some decisions. We can use this right part, this machine learning, as a tool that help us to find some complex correlations or complex relations hidden in the data, but still we are making decisions. So the machine learning is a set of techniques to achieve so-called weak or narrow artificial intelligence, which means that this model will be trying to do a very specific task, like drive a car or play a sound when time comes, doesn't matter. Okay? So as I promised, this is the starting point. Now you know that even if this right part is getting more and more complex, the left side part of this slide, so the intelligence, the making decisions, is crucial. It's still up to us. So, looks like you can get hurt by using some fancy tools if you don't know how they work precisely. Okay? It's true for almost any tool, like a hammer as well. Yeah. And when I first saw this AI visuals or integration between Power BI and artificial intelligence, and you know that right now it's weak artificial intelligence achieved by machine learning techniques, I was thinking that are we going in the right direction or not? Because based on some findings, based on some visuals, people there are helping us to make business decisions, and some business decisions can have huge consequences. Right now, it's very easy to say that something is wrong or good, or we should go in that direction, or fire those people, whatever else, whatever the business problem was. It will be better if you, as a Power BI specialist, knows how those fancy tools works. This way you will be protected from some bad consequences, not nice consequences of your actions or of your projects. So that's the true reason for this session. Let's see how AI fits into Power BI. There is a lot of things If you are a data scientist, you can work with Python and R in Power BI desktop directly. I'm sure you know that. And this is the final stage of this integration between Power AI and Power BI. But that's not the only option. So if you are not R or Python programmers, don't worry. There will be no R or almost no R or Python code shown during this session. If you're a BI analyst, you can work with Azure machine learning services or cognitive services and use your work in Power BI. That's great. And actually, you can do this even without Power BI premium license. But you still have to have Azure subscription, of course. So you can build a model, publish this model. I mean machine learning model. Publish this model on Azure, and use the train model for predictions directly from Power BI, which is great. But we are not going to do this during this session. We actually will be focusing on this end user part of this slide, okay? So we will start with those AI visualizations, and I will show you how to use them, and I will try to explain to you how they works actually, based on some specific examples. And then we also will follow these two parts, those two screens or pictures that I'm showing you right now. So we will prepare our data, our text data, so semi-structured data, in a way that this data can be used for BI modeling. And for this, we will use cognitive services, but from Power BI directly. Okay, so still no premium license needed. Instead, we will have to write a user-defined function in query formula language. So, if you have any questions right now, feel free to ask. If no, we will proceed. Yeah, so now you know what to expect from this session, hopefully. Okay, so if you remember the first slide, there is a fancy demo, yeah, simulation of how human brain works, and there were some lights, yeah. How, if the neurons get activated, it looks like the light was transmitted between them. And Microsoft took this inspiration for a moment, and some visualizations were marked with this lighting bubble. It's no longer the case, but it was like that, which means that those are directly related to AI, okay? And Microsoft changed its mind finally, because there is a lot of AI features built into different visualization. Probably you know that if you're plotting data using this line chart, you can forecast some data, so that's also AI, isn't it? Stuff like that, R, Python are directly related to data science in AI. So there is no longer those bubbles, but it was like that. And I took those three visualizations and I'm going to show them to you right now. So let me start with a baby example. It will be this one. Hopefully you can see clearly. So there is just a dozen or so training examples described by some variables. Those here are all the input variables. So they describe the conditions under happen during some surgeries. Yeah, it's related to eyes, so that's actually the real-world data. You will be surprised how often scientific research, or papers at least, are supported by 10 or even less examples, but that's the case. So I have nothing against this. And some of those patients, unfortunately, had to take follow-up operations or treatments. In the worst case, even evisceration, as you can see right here. And our goal is to find the reason why some surgeries went smoothly, there were no further complications, and why some patients had to visit hospitals for the second or third time. Okay, it's like that. Very simple variables, just true or false, easy, yeah? So what can we do with this data? We can first check if there are correlations between those variables. Okay, that's a person correlation coefficient computed here by using the custom R visual called correlation plot. Easy, yeah, to interpret, hopefully. So you can see that there is, let's say, statistically significant correlation between second graft and this variable less than 3 millimeters. Yeah. So if that was true, this also probably is true or would be true. But from the business user or doctor perspective, in this case, it means nothing. It's not interesting insight. So it will be okay. So I will try to speak up. So it will be better maybe if we check the correlation, if the correlation between variables. We can do this in R or Python. We can compute this Parson chi-square test correlation coefficient and get those p-values. Okay, the main idea between those values is that if they are quite small, yeah, that means that those two things, those two values of those two variables are unlikely to happen by chance. So yeah, there is a strong or significant correlation between this variable and the second graft, as you can see. We can confirm this. That's statistics, basic statistics. And from my experience, it's also not the finding that the customer was looking for, unfortunately. So we can do, maybe we can do better using those fancy BI visuals. And I'm going, as I promised, they will be explained later on. Right now, just be with me. So there is this one, key influencer used, and it was configured like that. I'm going to find key influencers. So I'm analyzing second graft in this case, based on all my input variables. And it looks like only one of them, surprise, surprise, this one, is statistically related or correlated with the output variable, which is good. We can even, there is even a factor compute, and you will learn how this factor was computed shortly. So it works like a charm. It looks better, And business user, and that's very important, can do this by itself. It's not that hard just to drag and drop some variables into explain by area and wait a minute to get a chart like that. That's good. So based on this, we can go even further. We can try to divide our training data or our data, our observations into smaller groups in such a way that influence this output variable. Okay? And it also looks great, but the result is completely different. Right now, this variable was used because those splits were done automatically. That's this II part of this visual. By the way, this visual is called the composition tree. Stay with me. You will understand how it works shortly. So when I changed the way I'm visually presenting my data, I got different results. Also interesting, but different. Right now looks like the most important factor for the second graft is perforation. If it happened during the first surgery, there is a high risk of second graft. Stuff like that. So you can read this tree like that by yourself. It's quite easy. Still remember and compare those results. So this the composition tree, this key influencer, this one, this row are functions, this correlation plot with the data. So surely we are getting some insight. It looks way better on the last two pages than here. Here I will have no clue why the second graft happened or based on what to predict it. So it works. That's important. Don't get me wrong, because soon I will start to complain about those visuals. But they are very useful. I'm not trying to convince you not to use them. Okay. So let's move on. And now try to remember, hopefully you can see the whole screen. Try to remember this slide, because it's crucial for the last 45 minutes or so. The first demo, so the first project we are going to do together in Power BI is all about calculating diamond prices. Okay? So we need some training data, historical data, and this data is available here. So on GitHub, it's actually part of tidyverse, or to be more specific, part of ggplot2, our package. Okay? But if you are not using R, don't worry, you can just follow this link and you will get this diamond CSV file. And inside, you will find 54,000 observations or records, okay? Or training examples, call them how you want, about diamonds. And the important variables are those 4 C's. The first one is carat. So we are measuring the weight of the diamond in carat. Please try to remember the question, What influenced diamond prices? Then there is a cut. So the quality of the cut is measured in this cut by this cut variable, and it can be fair, good, very good, premium, ideal. Ideal is the best. That's important. Okay, there are some questions. That's great. I will try to answer them later, but thank you for them. So we have a carrots, cat, color. The third one, it's a diamond color, from D, the best, to J, the worst. Try to remember it. I will show you this slide one more time, but if otherwise you will not be able to follow my example. Yeah. So carrot, cat, color, clarity, the measurement of how clear the diamond is, and it's still a categorical variable. The worst is L1, the best is if. Okay, it looks like this. Okay, so there are some small issues visible here, but there are no small issues if clarity is the best if. And there are also some physical measurements like depth, table. You can think about a table like a box, the smallest box that the diamond will fix in, like that. And finally, the price, important, because it's the output variable here, okay? And our task is to understand what influenced the price of the diamonds. Easy, isn't it? You can answer them directly right now. But we will do this using Power BI, short intro, and we will use for that natural language or Q&A visualization, okay? But we will do this using Power BI desktop. Then key influencers, okay? There were already some questions about key influencers, so I'm more than happy because the best question is a question that you have an answer for it on your next slide. Okay, so this key influencers work like that. If the output variable is a numeric one, it will build for you automatically the regression model, okay, linear regression model, and the result of this model will be showed you like that. Here is in Polish, but we will switch to Power BI desktop. It will be more understandable for most of you, probably in English. But important part is that there was a straight line found, that show us that output variable, the price, will change if some input variables like a carrot also change. Easy. If the output variable is a categorical one, which may happen, of course, categorical like we'll just take a set of predefined values. Text is obviously categorical variable. Instead of linear regression model, the logistic regression model will be built for you automatically. But it doesn't really matter. As you will see, both models are almost identical. And there is also this segmentation part, and the segmentation part works completely in different way. It uses a partitioning model. So it's actually built a decision tree behind the scenes to show you those important segments. Now we are focusing on the regression part. Quick recap: if you would like to predict the revenue, based on budget, you can collect historical data, plot them on the scatter plot like that, and your goal is to find correlation between input variable and output variable. And this correlation had to be linear, so a straight line. Things like that, And please notice those two parameters, B0 and B1. The goal is to find values of those parameters. That's it. That's the linear regression machine learning model for you. But of course, in practice, those input We are not limited to one input variable. We can have a lot of them. So the formula is getting longer and longer. But still, we are searching for the best parameters values. That's it. It may be like that. Why not? You can draw any numbers of straight lines on scatter plot, aren't you? But some of them are better than others. And to compare them, we will have to go back to this loss function I mentioned at the very beginning of our session. Okay, we will get about this aggregation as well. I'm going to show you that you can aggregate some data to get better insight. I'm referring to a question. Okay, so what's next? Looks good, looks easy, it's fast, but unfortunately, it doesn't always work. I mean this linear regression. If you want to use this tool, this linear regression algorithm, you have to be sure that those assumptions are valid for your data, okay? And the first assumption is obvious. There should be a linear relationship between input variables and an output variable. Otherwise, there is no way to draw a good straight line, isn't it? So those visualizations will do not check those assumptions for you. So if it's not like that, if there is no linear relationship, the model will be useless. Yeah? The predictions will be horribly wrong. But there is more. The second assumption is that there is, I will try to put it simply, that there is no outliers in your data. Please have a look at this picture or this on the bottom, on the right side of my screen, and try to draw a straight line that will, and try to draw it like that the goal is that the distance between this line and the actual data should be minimized. Okay, so without those 2 points, it's not that hard. It will be like this. Yeah, more or less. But the single observation, which is completely different from all other observations, will change the picture completely. Now, if there is just this single point, let's forget about this one, it will be like that, isn't it? We are trying to minimize the distance. With single point here, it will be headed more in this direction. So a single observation can influence the whole linear regression model, which means that if there are outliers, you have to deal with them beforehand, okay? And there is one more thing, and this is important for our case. I'm referring to those diamond prices. There should be no, or at least little, multicollinearity between data, which means that input variables should not be related to each other. If you remember this formula I showed you when I was saying that we are finding those parameters values, you will figure out why. Because right now, if there is a high correlation between price and X, Y, and Z, yeah, of this all input variables, aren't they? The output variable, carat, and X, Y, Z, the output variable is price. So those input variables are highly correlated. That means that the weight of those variables will be higher than it should be. Okay? So it's like that. This assumption also should be checked by you before you are going to use this key influencer visualization. So now let's check what we got from this. We are almost there. The very last thing I'm going to show you before switching to Power BI desktop is that logistic regression is actually not that different from linear one. In linear regression, we were drawing a straight line. Now, because the output variable was a numeric one, so we tried to predict the real number. Now we are going to predict a state, like if this customer is willing to leave the company or not, whatever else. So yes, no question, or we are predicting the color, or trying to find out if there is a dog on this picture, or cat, I should say. Doesn't matter really. So straight line is not so useful because probability of -5 or probability of plus 250 sounds silly. So we have to squeeze those numbers into the range between 0 and 1. And there are some functions which works exactly like that, sigmoid functions, which means that the input, so the output of linear regression is on the x-axis, and we are squeezing this output by using sigmoid function, so we will get the probability between 0 and 1. That's for binary classification, but it works like this also for multi-class classification, more or less. So with this, we are almost done. We can just take a threshold, like 50%. All probabilities above the threshold will be marked or assigned as the class 1, and observations that the predictions will get the lower score will be assigned to class 0. And we're done. Okay. So with this, let me switch to Power BI. This one. And if you remember, we are working with those diamond data set. By the way, it's a great data set. I highly recommend to spend some time playing with this data set. And let's start by using this Q&A visual. It looks like that. So if you put a Q&A visual on your report, you will even get some sample questions to help you start working with this visual. So I was interested in average price by cut. And what do you think about this? So I got exactly what I asked for in the nice form of this bar chart. But the average price for premium cut is 4,584. For ideal is 3,457. Is it right or not? What's going on here? What do you think? Let me go back here to this important slide. And cut. The ideal was the best, the fair was the worst. Let's go back here. Ideal was the best, fair was the worst. Counterintuitive? Maybe. So then I tried to ask a question like that. So it's natural language question, isn't it? The easiest form of getting insight from your data is just to ask data. So I'm asking my data, give me the average price by carat as line chart, because I would like to see the line like this. And it looks like there is a strong correlation between the price and the carat, but not all examples follows this trend. Okay. Finally, I did something like that. So I ask compare price and carat as scatter chart by color, and I got only few points. This point is for color D. This point is for color J. This point is for color G. Okay, so you can get the idea. So that aggregation behind the scene, and there is a strong correlation. But again, please remember this part. The worst was G, the best was D. Really? Why is like that? Okay, so that was the first part, the first visualization. You can ask question, you can ask your data, yeah, what's inside, but be careful because you will get the answers like that. And now the point is to understand why. So let's switch to correlation plot again. Now you can see that there is so now we are checking our assumptions because we are going to use this key influencer visualization, and you know that the key influencer works by training a regression model for you. Can we do this using all our input variables? Probably not. So let's go here and have a look at the results. I have nothing against linear regression or logistic regression. They are great. I'm using them. So it looks like that. The first visualization used here, I will show you the configuration. So I'm explaining price by all my input variable. Looks like that, more or less. Okay? And there are some findings. So the price goes up because I choose what influence price to increase. When carats goes up to 0.47. And I even got the visualization of this. Okay? Looks good. Looks good. And now you even know how this value was computed. That's the parameter value that machine learning model, this logistic linear regression model found for carat input variable. Yeah, so it's B something like B4 or for whatever. Good, good, looks good. Yeah. But what next? Then, if color is J, the price is on average higher. Again, please remember this. Color is J, yeah, the worst one. But the prices are higher. Why? And so on and so forth. Okay, so it looks like that. That was linear regression, and that was logistic regression for you. Yeah, so now I'm checking this color. It looks like that. And you can logistic regression, which means that the output variable is categorical one, like the clarity, whatever, and so now you can play with those variables as you want. So now I'm checking what influenced the clarity of the diamond. Maybe it's a valid business question. I don't know. So you will get the results like that. Nice, but not true, not always. So what can we do to improve the quality of these results? Here, I use the same data and I use the same visualization, and the results are perfectly valid. What have I done? I have excluded some old input variables. So now I'm explaining price by carat only, and that's good. So if I know this beforehand, I can apply this visualization, I can get confirmation. this model works. And even I can do something fancy like this. Here, as you can see, I use this expand by. Sorry, I will try from time to time show you. Yeah? There's an expand by field, and I put color here, okay? And this looks almost exactly like the visualization created by Q&A, yeah? Visualization on the first page of this report. So it happens that the mechanism behind this is actually the same. So data is being combined by color, okay? And then the price, I'm analyzing the average price per group, per segment, so per color. You can do this like this, so you can know how it works. You can actually get some valuable insight from this visualization. And the top segments, is the transition one. So we are moving to the next visualization. We have to manage time still. So this works perfectly fine. My data was divided into segments. The number of segments was found for me automatically. I can check what's interesting in this segment because I'm willing to spend this amount, yeah, to buy this diamond. So if I'm looking for diamond like this, in terms of price, I should ask for a diamond heavier than 1.67 carats. It's like that. Yeah, so useful. Why not? And it works well. Maybe you noticed. So those results are actually valid. Okay. So we are right. So we are here. The final remark about logistic regression is how to compare those straight lines or those curvy lines to find the best one. And for this, we need a loss function. For regression is quite easy because we can just compute the average distance between the data point, and the model. Okay. Then we have to do something with the sign because sometimes the model can overrate, sometimes it can underrate. So we can square those differences, sum them up, and divide by the number of observations. And we will get the L2 loss function. It looks like that. Our goal is to minimize this function. Okay? Easy. So now you know even how those lines were found or computed. But there is one more visualization available for you in Power BI. And it works completely differently. Now we are switching from regression algorithm to partitioning algorithm, like decision tree. And exactly decision tree is being used by the next visual. So decision tree looks like this graph, yeah? So we can divide the examples into subsets based on input variables. The goal is to find interesting subsets, like all those subsets where, I don't know, there was a dog or a cat visible on a picture, or all those customers who are going to leave the company. So the point is how to find those branches, yeah? How to divide the data into subsets. We can start with a single variable, then we can follow up in recursive manner to find another subset, and so on and so forth. That's why those algorithms are called partitioning algorithms, partitioning models. An interesting fact about partitioning algorithms is that they can work with any data. If there are outliers, they don't care. If there is multicolorality between input variables, they don't care. They just works, and the results are precise and reliable. That's good, isn't it? Finding the best splits is slightly more difficult because we are working with categorical variables, so mostly in this case. So it can take only two states, yes or no, if it's binary. So we have to transform this yes/no curve into something better that we can optimize better. But the idea is to make as many good predictions as possible. Okay. So if if the observations was in class A, the model should set A. If it was in class B, the model should say B, and we can just count those results, those predictions. And with this, we can understand how key influencer segment works. Yeah, I showed you this already, but also how the composition tree works. And this is, in my opinion, the best way to get insight from your data. Use the composition tree. So the composition tree was used here. Let me go back. It was configuration was really simple. There you go. So I'm going to analyze the second graph based on input variables. And now you can choose the function, the aggregation function used as a loss function for this example. So the algorithm, the decision tree will be built to find a different count of second graph variable. This variable was a binary variable, yes, no. So count is only option here. But if I go back here to our diamond prices, price is a numerical variable, isn't it? So here, let's wait. Okay, I can choose different aggregation functions. Okay, so I ask for sum. That was probably a mistake. Yeah, it makes more sense to check the average of price. Yeah, the average price of diamonds. So I will switch to average, and I will get completely different results. Okay, so now by using this visualization, you will understand why all those previous visualizations were not so reliable, because there is a high correlation between carat and price, which means that the clarity or the cut doesn't matter. If the diamond is heavier, it still will be more pricey. Okay, looks like that. So here we got perfectly valid results. Just please be careful with choosing the aggregation function, and you can the important part, this bubble, light bubble here, means that the carat was chosen for me automatically as the best split, and then I follow the procedure, yeah, to the end of my variable, and I ask for higher I can ask for lower. Now you know why it looks like that, because still we have to correct the average, the aggregation function. Good. And you will be fine. Easy. Okay, so that was the composition tree. We have like 20 minutes, 15 if we, then Q&A. So the last part is how to prepare your data for modeling. So now we are switching from analyzing, getting insight from your data to preparing your data. So we will move from Power BI to Power Query. And but the AI, artificial intelligence used to prepare your data will be far more complex. And I will use cognitive services, okay? Maybe you know those cognitive services, probably most of you do. There are services available. You can use them for sentiment analysis, key phrase detection, and so on and so forth. Okay, ready to use language models, not only language models, also vision models as well. And my second demo, or my third really, is about natural language processing. So let's say I got those opinions about self-driving cars collected, and I would like to get the sentiment from this free-form text. I even managed to find a data set, it's here, already labeled by students. So the higher the value here, the better approach or opinion of this respondent about self-driving cars. More positive, I mean. So 3 is neutral, 5 is highly positive. But this is just to demonstrate you how cognitive services works. In real world, you will not have this label. So our task is to generate this label, okay? How to do this? We can use text analytics API. You have to have Azure subscription for this. That's true. But that's it, okay? So it's not completely free. All technical details you will find here in the documentation of this API. You will also find some code samples, sample requests, even testing console, so you can play with this API, with this service by yourself. Easy. But I would like to use it from Power Query. For this, I have to write a custom Power Query function. And this function looks like that. Here is in Polish key for this service, which means that I have a subscription, I provision this service, I can use it. And an endpoint, so URL. And then this part will be repeated. You will see it on next slides as well. So I'm sending the text in JSON format taken from my table, okay? So it's here. I'm preparing this JSON request. Text is in the body and header is like that, my API key. That's a response I got from the service. I unpacked the text from JSON document, okay? And part of the response will be the score. So I'm taking this score as a sentiment, and that's it. So that's my function. And I use this function to build a last page of my report. So that's my sentiment score, computed by Azure Cognitive Services here. And then I try to play with it a little bit. So I compare the distribution on this sentiment with the label, so the manual work of those students. More or less the same, isn't it? So that's good. And even I check the average, yeah, by label. Also looks good because if the label is higher, 5, the average sentiment is also higher, 0.68 for 5, 0.32 for 1. So we are working in the same direction, which is shown here. Yeah, that's good. So I verify that this text API is working more or less like those students, which is good. And you can do the same for different services, cognitive services. For example, you can detect the language, and I will show you this right now here. So now I will go to data, transform data, so Power Query Editor. And there are, yeah, that's my data already enhanced, as you can see, because it's painfully slow. That's the important part. If I have a Power BI Premium, I could click here, Text Analytics, and I will be able to call those functions directly from Power BI. The performance is completely different, but I don't have. So I had to write, So I had to write this function, custom Power Query function, and call it row by row. So that's slow, but it works. Let's say we will check the detect language. Witam Katowic. Cześć. So, okay, I will not show you the live because looks like this Power service is already down. Okay, I forgot to bring it alive, unfortunately. Sorry for this, but it's exactly like I show you on the slides. So now I can show you the keys if the service is done. So it's exactly like I show you on slides. The function defined here, and this function was used here. So I was just calling my function. It looks odd here, but you can use the graphical interface to call your custom function from Power Query. Okay, and as a result, I got this sentiment. It works like that. Slowly, but it works. So that was the detect language, key phrases. The differences are here. So I'm changing the URL to call the right service. And of course, I'm returning from this function the correct part of the response. Here is just a list of key phrases, which brings me to the very last demo, an important message, important fact that I would like to show you. I can use this key phrases API to get results like this. So I extracted from those opinions key phrases, and the most popular visualization of textual data is this cloud, yeah, of words. So I use this. Key phrases that's a custom visual in Power BI, by the way. So I use it, and I got the cloud like this. But I also found a visual that works directly on free-form text, on these comments. Just by using regular expression, simple but fast, I will get results which looks, in this case, very similar to me. And it's working here. So that's the sentiment analysis. If you remember, our goal here was to compare the score, the sentiment score found by cognitive services with the score with the labeled put down by students. And it works. That was my impression. And finally, I was asked, let's assume that I was asked to generate those clouds of words. So I did it. I did it here using a custom visual, this one, word cloud. Important part is that I used the free-form text as a source, as you can see here. And it works. So I solved my problem for free and fast. And then I used the same visual, but now I did through this whole process of using cognitive services to find those key phrases. So now the input column are key phrases found by cognitive services. If you think that it was worth waiting, in this case, like 4 hours, that's good. But my point is that simpler methods are not necessarily worse. Okay? So consider at least them before switching to those advanced AI things. Okay, so with this, it's time for questions. Yeah, I was talking for more than an hour. Time for you.
Yeah, thank you so much. So we are ready to have some questions. So guys, please, if you have any question, please drop a line on the YouTube chat.
Yeah, looks like we have a question about 0.5 and neutral. So looks like it's about sentiment analysis.
Okay, so it might be for yeah. In this specific, yes. So if I got this question right, yeah, this cognitive services works exactly like this. 0.5 means neutral result. That's true. But it may be different if you use the different API or different service. If you were asking about this, that's the simple answer, yeah. Microsoft decided that 0.5 is a neutral. If you ask about this linear logistic regression things and the threshold, so it's that default threshold, but it's also up to you to move it up or down, depends on your needs. Okay, does it answer your questions? Yeah, I can see that there is a question about Power BI files and presentations. So that's actually a question for you guys. Yeah, more. I can show you the diamonds report and presentation. No problems. I'm willing to share it. The small one about patients, I'm not so sure. I'm not allowed to give it away.
Yeah, I guess I'll allow the presentations and files from Martin will be able to share on our pages. Yeah, and it would be open for everyone, as you did it for our previous presentations.
And also about
Great.
the video, you can watch it on the YouTube channel, so this is not a problem. So guys, any other question?
Opinions, maybe?
At least.
So what do you think about Power BI AI capabilities or about those data sets I showed you?
So it seems to me probably we do not have any question right now. And yeah, I really want to say thank you for this great presentation. It was very informative. We really like it. Thank you so much. And it seems to be this is all for today.
Yeah, guys, thank you so much for being with us today. And we have one more surprise for you. So we are going to raffle gifts from our friends from Scalia. So we'll use random for that purposes, and they will share the results with you on our LinkedIn and Facebook pages. So all updates are on our LinkedIn and Facebook pages and our YouTube channel. Yeah, don't forget to subscribe to our YouTube channel not to miss any updates and videos or upcoming streams. So thank you everyone again. See you at our next sessions. Thank you, Martin. Thank you, everyone.
Yeah,
Thank you.
And actually, thank you from my side. Thank you, guys. Thank you, Martin. And thank you, our friends from Scalia Company. So, guys, be smart and safe. Bye-bye.
Bye.